When reliable power is required around the clock, industrial gas turbines become critical machines. And in the oil and gas industry, one name found in demanding mechanical drive and power generation applications is the Solar Turbines Titan 250. The Titan 250 is a high-performance industrial gas turbine manufactured by Solar Turbines, a Caterpillar company. It is designed for demanding continuous duty applications where availability, efficiency, and dependable operation are extremely important. The Titan 250 is particularly well suited to the oil and gas industry, including pipeline compression, gas processing, and other mechanical drive applications. It can also be configured for industrial electrical power generation. In current published configurations, the Titan 250 generator set is rated at approximately 23.1 megawatts of electrical output under ISO conditions. For mechanical drive service, the package is rated at approximately 23.8 megawatts, or about 31,900 horsepower. One important feature of the Titan 250 is its two-shaft design. The gas producer generates the high-energy gas flow, while a separate free power turbine converts that energy into useful shaft power for the driven equipment. During operation, atmospheric air enters the engine and passes through its multi-stage axial compressor. The compressed air then enters the combustion system, where fuel is introduced and burned. The resulting high-temperature gases expand through the turbine stages, producing power for the compressor and the external load. The Titan 250 incorporates a 16-stage axial compressor. Multiple compressor stages progressively increase the pressure of the incoming air before it reaches the combustion section. For mechanical drive applications, the Titan 250 achieves approximately 40% shaft efficiency. This combination of output, efficiency, and continuous duty capability makes the machine particularly attractive for large compressor drive applications. But what happens when an existing Titan 250 reaches the point where replacement, repowering, or a major plant upgrade is being considered? This is where the engineering becomes more complicated. There are gas turbines from other manufacturers that can be evaluated as potential alternatives. However, similar power output does not mean that another turbine is a direct drop-in replacement for the Titan 250. One of the first machines worth evaluating in a similar power range is the Siemens Energy SGT-600. In simple cycle power generation configuration, Siemens publishes approximately 24.5 megawatts of electrical output with gross electrical efficiency of approximately 33.6%. For mechanical drive applications, the SGT-600 is also available in the same general power class, making it one of the more relevant machines to investigate when the required output is relatively close to the Titan 250. If additional power is required, an aero-derivative option can also be considered. GE Vernova's LM2500XPRESS G4 provides approximately 34.5 megawatts of output, with published net efficiency of approximately 39.4% under specified conditions. The LM2500 family uses aeroderivative gas turbine technology. This makes it a different design philosophy from a traditional heavy industrial turbine package, and that difference must be considered when evaluating maintenance strategy, installation requirements, and lifecycle economics. For applications requiring substantially higher mechanical drive power, another candidate is the Siemens Energy SGT-A35. Depending on the specific variant and configuration, this machine operates in a significantly higher power range than the Titan 250, with mechanical drive efficiency around the 42% class. Looking only at power output, the SGT-600 sits relatively close to the Titan 250, while the LM2500XPRESS G4 and SGT-A35 move into higher output ranges. But power rating alone is not enough to determine the best replacement. For a mechanical drive installation, one of the most important questions is whether the new turbine can properly match the existing driven compressor. Available shaft power, output speed, operating speed range, torque characteristics, and compressor performance must all be evaluated together. The physical package is equally important. A replacement may require changes to foundations, inlet, and exhaust systems, fuel gas piping, lubrication systems, electrical equipment, ventilation, fire protection, auxiliaries, and the overall plant layout. Control system integration can also become a major part of the project. The turbine controls must communicate correctly with the compressor controls, plant distributed control system, shutdown logic, vibration monitoring, and safety systems. Fuel composition, emissions limits, and local ambient conditions can also change the final answer. Elevation, temperature, humidity, and fuel quality affect actual site-rated performance, so ISO nameplate ratings should never be used as the only basis for replacement selection. Finally, engineers must look beyond the purchase price. Fuel consumption, maintenance intervals, overhaul strategy, spare parts availability, downtime, service support, and expected operating life can have a major impact on the true life cycle cost of the replacement. So, which turbine is the best replacement for a Titan 250? There is no universal answer. If similar power is required, the Siemens SGT-600 deserves serious evaluation. If additional capacity is part of the project objective, the LM2500XPRESS G4 or SGT-A35 may become attractive candidates. But every option requires a complete technical and economic study. The most important lesson is this. Replacing a gas turbine is not simply a matter of finding another machine with a similar megawatt rating. The turbine-driven equipment and complete plant must be evaluated as one integrated system. The Solar Titan 250 remains a powerful and efficient industrial gas turbine, particularly for continuous mechanical drive applications. Understanding its design and performance is the first step toward evaluating any future replacement correctly. If you found this technical overview useful, subscribe to the channel for more practical videos on gas turbines, compressors, maintenance, and rotating equipment.